Just before 3 in the morning, the ground beneath one of the most densely populated volcanic regions on Earth shook hard enough to jolt people awake. And by sunrise, scientists confirmed it wasn't a single tremor. It was another chapter in a swarm that has been building beneath Naples for months. 500,000 people live directly inside this caldera, many of them in neighborhoods built right into the collapsed volcanic crater itself. 3 million more live in the surrounding metropolitan area. And right now, the ground underneath all of them is rising, cracking, and trembling in a pattern that hasn't fully calmed down in years. The area in question is Campi Flegrei, which translates to the burning fields, a sprawling volcanic caldera sitting just west of Naples, Italy. Unlike Mount Vesuvius, the more famous volcano that looms over the same region and destroyed Pompeii nearly 2,000 years ago, Campi Flegrei doesn't have a single dramatic peak. Instead, it's an enormous depression formed by violent eruptions roughly 40,000 years ago. A caldera so massive that entire neighborhoods, roads, and even parts of the city of Pozzuoli sit directly inside what was once the volcanoes. Collapsed crater. That geography is exactly what makes this particular swarm so unsettling. There's no single mountain to watch. The unrest is happening directly underneath people's homes. The overnight swarm that triggered renewed attention began with a shallow tremor, recorded at just after 3 in the morning local time, waking residents across multiple towns, with its epicenter placed squarely between Pozzuoli, Agnano, and the Solfatara. 3 areas sitting right at the geological heart of the caldera. Italy's National Institute of Geophysics and Volcanology, known by its Italian acronym INGV, confirmed the earthquake reached a depth of roughly 3 kilometers, shallow enough to be felt clearly by residents across the region. A second, smaller tremor followed shortly after, and then a series of additional smaller shocks continued through the overnight hours, the classic signature of what scientists formally classify as a seismic swarm rather than a single isolated earthquake. This overnight event is far from an isolated incident. It's part of a much longer pattern that INGV's Vesuvius Observatory has been tracking closely for months, publishing detailed weekly bulletins that read almost like a slow-motion countdown. In the week, spanning June 29th through July 5th, the observatory logged 43 separate earthquakes within the caldera, part of 2 distinct swarms, one beginning late on July 1st with 22 tremors, and another starting in the early morning hours of July 4th with 7 additional events. The following week, from July 6th through July 12th, activity actually eased somewhat, with 38 total events and a reduced count of 20 located earthquakes, a pattern researchers noted as a meaningful drop compared to the intensity of the week before. But this kind of up and down fluctuation has become the defining rhythm of Campi Flegrei's unrest, brief lulls followed by fresh spikes, rather than any single sustained trend in one direction. The ground itself is telling an equally dramatic story. Since 2005, the caldera floor has risen approximately 140 centimeters, nearly 4.5 feet of accumulated uplift, a process volcanologists call Bradyseism, essentially the slow, breathing rise and fall of ground level caused by pressure changes deep within the volcanic and hydrothermal systems below. Recent monthly uplift rates have hovered around 10 to 15 millimeters, though earlier in 2026, that rate briefly accelerated to roughly 25 to 30 millimeters per month, following a significant swarm in February of 2025, before gradually settling back down. To put that in perspective, a rate of even 10 millimeters a month, roughly the thickness of a fingernail, might sound small in isolation. But sustained over months and years, it adds up to a caldera floor that is measurably, undeniably rising beneath the feet of everyone living on top of it. Scientists studying Campi Flegrei have identified a direct and consistent relationship between this ground uplift and the frequency of earthquakes. An understanding that connection is key to understanding why the swarms keep happening. As magma and hydrothermal fluids shift and accumulate beneath the caldera, they place enormous stress on the surrounding rock. That stress doesn't release smoothly. Instead, it builds until it exceeds the rock's ability to hold, at which point it fractures, producing exactly the kind of shallow clustered earthquakes that have been rattling the region with increasing frequency since 2018. A team of researchers, including scientists from Stanford, recently developed an artificial intelligence model capable of detecting far more of these tremors than traditional monitoring ever could, more than quadrupling the number of identified earthquakes in data collected since 2022. What they found was sobering: thousands of small quakes that had gone completely undetected using older methods, suggesting the caldera has actually been even more seismically active beneath the surface than official records previously showed. The scale of recent activity puts the current swarm into sharper context. Back in February 2026, during the week, spanning February 23rd through March 1st, INGV recorded approximately 70 earthquakes in a single week, with magnitudes reaching as high as 3.5, concentrated almost entirely beneath Pozzuoli and the nearby Agnano area. That represented one of the more intense weekly totals recorded in recent years, though activity did ease somewhat the following week, dropping to 47 events, still elevated compared to long-term background levels, but a genuine relief after the spike. Even further back, in May of 2026, a shallow magnitude 4.4 earthquake struck offshore in the Gulf of Pozzuoli, triggering a swarm of 12 total earthquakes and rattling the entire Naples metropolitan area strongly enough to prompt precautionary building checks and temporary closures across the city. For residents living inside and around the Caldera, this isn't an abstract scientific curiosity. It's become part of daily life. Communication protocols established jointly between the Vesuvius Observatory, the Pozzuoli Prefecture, and local municipal authorities mean that even minor swarms now trigger official public notifications almost immediately, keeping residents informed in real time as sequences develop and eventually conclude. That level of coordinated communication reflects lessons learned from Campi Flegrei's history, because this isn't the Caldera's first period of dramatic unrest. Between 1982 and 1984, the region experienced a major crisis marked by nearly 2 meters of ground uplift and more than 10,000 recorded earthquakes, some exceeding magnitude 4, severe enough that authorities were forced to urgently evacuate large portions of historic Pozzuoli. An earlier, similarly intense episode had also struck the area between 1970 and 1972. In other words, Campi Flegrei has a documented history of cycling through periods of dramatic unrest, followed by longer stretches of relative quiet, and many scientists believe the current activity, ongoing since 2018, represents another chapter in that same long-running geological cycle. Beyond the seismic and deformation data, scientists monitoring Campi Flegrei rely on a dense web of instrumentation spread across the caldera and its surrounding waters. The permanent GNSS network, essentially a high-precision satellite positioning system, similar to GPS but accurate enough to detect ground movement on the scale of millimeters, currently consists of 39 separate land and marine stations positioned throughout the region. These stations feed continuous data back to the Vesuvius Observatory, allowing researchers to track uplift patterns not just across the caldera as a whole, but at specific, localized points within it, since different sections of Campi Flegrei have shown slightly different rates of deformation, depending on their proximity to the areas of greatest underground pressure. This granular level of monitoring is part of why scientists can speak with such precision about exactly where recent swarms have concentrated, whether that's beneath Pozzuoli, Agnano, the Solfatara crater, or the Monte Olibano sector, each of which has produced its own distinct clusters of activity throughout 2026. Comparing Campi Flegrei to other actively monitored volcanic systems around the world helps put the scale of this unrest into perspective. Researchers involved in developing the newer AI-based earthquake detection models have noted that similar approaches could eventually be adapted for other regions experiencing comparable unrest, including Santorini in Greece, which experienced its own prolonged earthquake swarm at the beginning of the year. What makes Campi Flegrei particularly significant within that broader context isn't necessarily the size or frequency of its individual earthquakes. Most remain relatively small, generally below magnitude 4, but rather the sheer number of people living directly within the hazard zone combined with the caldera's well-documented history of large-scale eruptions dating back tens of thousands of years. Very few volcanic systems on Earth combine this level of population density with this degree of active, ongoing ground deformation, which is exactly why Campi Flegrei receives such intensive, continuous scientific attention compared to many other restless volcanic regions worldwide. The distinction between the current unrest and an actual eruption threat is one that scientists and civil protection officials work hard to communicate clearly to residents, precisely because it's so easy to conflate the two. Ground uplift, elevated seismicity, and increased gas emissions are all considered precursor signals in volcanology, meaning they indicate that pressure and stress are actively changing beneath the surface, but none of them, individually or combined, guarantee that an eruption is close at hand. Campi Flegrei has experienced multiple extended periods of exactly this kind of unrest throughout recorded history without progressing to eruption, including the 1970s and 1980s crises mentioned earlier, both of which eventually subsided into longer periods of relative calm rather than escalating further. That historical precedent is part of why INGV's current classification, accelerating unrest without imminent eruption risk, reflects a genuinely evidence-based assessment rather than either complacency or unwarranted alarm. Still, officials aren't treating the situation passively. Local evacuation planning across the Pozzuoli area has been updated and refined multiple times in recent years, taking into account lessons learned from the 1982 to 1984 crisis, when the sudden intensity of that swarm caught many residents and even some officials off guard. Modern evacuation routes, communication protocols, and public education campaigns are all designed with the specific goal of avoiding that same scenario, ensuring that if activity does eventually escalate toward genuine eruption precursors, both authorities and residents have clear, rehearsed procedures to follow rather than improvising under pressure. Civil protection drills involving local schools, hospitals, and municipal offices have become a regular feature of life in the towns sitting most directly atop the Caldera, a reflection of just how seriously the region takes its unique and ongoing geological situation. If you want to stay updated as this swarm and Campi Flegrei's broader unrest continue developing, go ahead and like this video and subscribe, because this is a story we're going to keep following closely as new data comes in from Italian monitoring agencies. Despite the scale and frequency of recent activity, INGV has been consistent in its official messaging, classifying the caldera as being in a phase of accelerating unrest, but explicitly stating that no eruption is considered imminent based on current data. Italian civil protection maintains what's known as a yellow alert level, officially described as a state of attention, one step above baseline monitoring, but well below the kind of emergency classification that would trigger mass evacuation planning. Geochemical monitoring of the region's fumaroles, natural vents releasing steam and volcanic gases, continues to show elevated sulfur dioxide and carbon dioxide emissions, alongside long-term hydrothermal system heating. Additional signal scientists track alongside seismicity and ground deformation to build the most complete possible picture of what's happening deep underground. Perhaps the most sobering piece of recent research comes from a peer-reviewed analysis projecting that the volcanic system beneath Campi Flegrei could reach what researchers describe as a critical mechanical threshold sometime around 2033, a projection based on modeling the accumulated stress within the caldera's crust T over time. It's important to understand that this kind of projection isn't a prediction of an eruption on a specific date. Volcanic systems remain notoriously difficult to forecast with precision, but rather an estimate of when the underlying rock could reach its physical breaking point under continued pressure, a threshold that would likely manifest as further escalation in seismic and deformation activity rather than an immediate, sudden eruption. Scientists studying Campi Flegrei continue to stress that ongoing monitoring, especially newer AI-assisted detection methods capable of catching tremors that older systems missed entirely, represents the clearest tool available for understanding how this restless, volcanic system is actually evolving beneath one of the most densely populated coastlines in Europe. And for now, that continuous flow of data remains the single best defense the region has against being caught by surprise.